Hey guys, now we're ready for chapter 10.2, which I must admit is a little more complicated than 10.1. Because this time we're actually going to talk about two events occurring. So the probability that both of the events are going to occur, right? So if I think of two events and I want to find the probability of them both occurring, I need to make a decision about whether those events are independent or dependent. So let's start with the simpler possibility, and that's that the events are independent. And what do we mean by that? We mean the events are independent when the outcome of one event does not affect the likelihood of the second event. So some of our answers here are going to be common sense answers, right? So what we're going to do is we're going to find kind of just our common sense answer, and then we're going to use this little formula here to verify that our common sense works. So probability of A and B is the probability that both events occur. Okay, so if they're independent, it's super simple. All I need to do is to find the probability that both events occur, I just need to multiply the probability of the first event times the probability of the second event. So let's see how this works in real life. Okay, so we have our student who didn't study for his or her test again. This time the student randomly guesses on a 2-question true or false quiz, short quiz. Let's look at two events. Event A is that the student guesses correctly on question 1, right? And event B is that the student guesses correctly on question 2. So let's just use our common sense, and what are those events dependent or independent? Or in other words, is the likelihood of guessing correctly on event 1, if I guess correctly on event 1, is that going to change the likelihood that I'll guess correctly on event 2, right? And the answer is no. Those are separate questions. So we're going to say the answer here is independent. And I would say the reason why is because my chance of getting question 2 right is not affected by whether I get question 1 right. Right? So, and that's just common sense, right? Those are separate questions if I just randomly guess. Okay, so let's use our formula to determine or prove that we were right with our common sense. So what I want to do first is let's just write out the possible outcomes, the possible ways that the student could have guessed the questions. Well, the student could have guessed the first one correct and the second one incorrect, right? Or they could have guessed the first one incorrect or the second one correct. Or they could have gotten both of them correct or both of them incorrect, right? Those are 4 possible outcomes. Okay, so let's do the probability that we want to use the formula. So we're going to try to find the probability of A and B. So in this case, it's the probability that both are correct. Well, let's look at the probability of A. Event A is that the student guesses question 1 correctly. Well, how many ways can the student guess question 1 correctly? 2 out of 4. Oh wait, let me write the note, sorry. I'm going to write this out. It's a good thing you guys have filled in notes, right? Because this takes a long time. Okay, so let's say we want the probability of both of them being correct. The probability of getting question 1 correct is 2 out of 4. And the probability of getting question 2 correct is also 2 out of 4. Right? So what's the probability that both are correct? Well, the probability that both are correct is 1 out of 4. So did we just create a true equation? Is this true? Well, let's see. is 1/4 equal to, now let's reduce this to 1/2. And let's reduce this to 1/2. Is 1/4 indeed equal to 1/2 times 1/2? Yes. We have just proved that they are independent using our mathematical model, even though we can pretty much figure it out using common sense. Okay, let's look at the more complicated case, and that is when events are dependent. So if I want the probability of two events occurring when they're dependent, I have a different formula. So let's talk about what are dependent events. Well, dependent events are when the outcome of one event does affect the likelihood of the second event. Now this is a little bit confusing because we think of this slash meaning divided by, but in probability speak that isn't what it means. So this means is the probability of both A and B is equal to the probability of A times the probability, and this slash means given that A has already happened. Right? So here we're getting into some philosophical stuff. Sounds like it. So that's what this means. This means the probability of B given that A has already happened. Okay, this one's a little annoying. I have to give you a little heads up. Okay, guys, we have a group of students that includes 1 boy and 3 girls. The teacher randomly selects 1 student to be the speaker and 1 to be the recorder. So event A is selecting a girl to be a speaker and then selecting another girl to be the recorder. Okay, first let's use our common sense. Are those events dependent or independent? Or in other words, if I select a girl, the first for the speaker, does that change the likelihood that I'm going to select a girl for the recorder? Well, yes, because if I select a girl for the speaker, how many kids are left to play the recorder role? Well, instead of 4, there are now 3, right? So if I select a girl, if you select a girl as speaker, right, there's 1 fewer girl left for recorder. So I can say it as, I might have said it eloquently here. Oh, so now the sample space goes down to 3 students that can possibly be chosen as recorder. Right, so we can tell here that it is going to affect, if I pick a girl first, now there's only 1 boy and 2 girls left to be recorder. Okay, here's the annoying part, guys. Let's look at the total outcomes. And then we're going to use our formula. So let's look at the speaker. What are the ways how many possible options are there for the teacher to choose speaker? Well, they could choose girl number 1, they could choose girl number 2, they could choose girl number 3, or they could choose the boy. Right? Okay, well, so what are my possible ways to get recorder? Well, if I chose girl 1, then I could get girl 2 as the recorder, girl 3 as the recorder, or the boy. Right? Here, I could get girl 1 as the recorder, girl 3 as the recorder, or the boy. You get the idea? Here I could get girl 1, girl 2, or the boy. And here I could get girl 1, girl 2, or girl 3. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. Okay, so let's use our formula, which is up here. The probability of A and B. So in this case, we're going to say the probability of both girls is equal to the probability of a girl speaker probability of a girl recorder given that a girl speaker has happened. Okay? Okay, guys, so let's look at this. The probability that they're both being girl, that there are both girls. Okay, well, let's count how many are both girls. Maybe I'll underline or circle it. 1, 2, 3, 4, 5, 6. There are 6 possibilities that both of them are girls out of the 12. Okay? Okay, guys, what is the probability that the speaker is a girl? Well, the probability that the speaker is a girl, well, let's look here. It's 3 out of 4. Oh, that's a better pen. Okay. What is the probability that the girl is a recorder given that there's already a speaker, that the girl's a speaker? Okay. Well, let's look. Yeah, that's right. Sorry. The probability that a girl is set that we choose a girl as a recorder, given that the girl's already a speaker, is wait. Now I'm all confused. Can you pause it? Can we